Imagine if you could learn anything, not by memorizing boring formulas or repeating definitions, but by truly understanding it so it stays in your mind for life. Imagine if the ideas you explore today become part of how you think tomorrow instead of vanishing the moment an exam ends. That's what I want to share with you today. A method I've used my entire life, one that helped me understand the deepest mysteries of the universe and made learning exciting instead of stressful. This is the method I used to become a physicist, to think clearly and to enjoy discovering the world. And the remarkable thing is, it works for anything: physics, math, history, art, even skills like playing an instrument or solving complex problems in everyday life. I've never believed in memorizing things just to pass a test. Memorization is temporary. You can repeat formulas over and over. You can recite definitions perfectly, maybe even impress someone in the moment. But the instant you stop thinking about it, it fades. True understanding is different. True understanding means you can take an idea apart, look at it from different angles, and explain it clearly to anyone. And the moment you can do that, the knowledge becomes permanent. The first step is simple but often overlooked. Pick a topic you really want to understand. It can be anything. Let's take gravity as an example. Most people just memorize Newton's law. The force is proportional to mass and inversely proportional to distance squared. They might even plug numbers into formulas and get correct answers, but do they really understand it? Probably not. Real understanding begins when you study the topic, think about it, connect it to what you already know, and ask yourself questions. Why does gravity exist? How does it actually work? Why does it weaken with distance? How does it affect the motion of planets, the fall of an apple, or even the ocean tides? These questions are where curiosity comes in, and curiosity is the engine of learning. Without curiosity, memorization is all you have, but curiosity turns learning into an adventure. Once you have studied the topic and gathered the basic ideas, the next step is magical. Take a blank sheet of paper and start explaining it. Imagine you're teaching a child who knows nothing about the topic. Speak as if the child is right in front of you. Write down every detail, every connection, every step. Pretend you are at a blackboard. As you do this, something incredible happens. Suddenly, you notice the gaps. You realize the parts you thought you understood are actually fuzzy. Maybe you can describe the motion of planets but can't explain why they follow certain paths. Maybe you understand the idea of mass, but you can't explain why heavier objects fall faster in some situations. That's not failure. That's progress. That's exactly what you need to learn. The gaps in your understanding are your treasure map, pointing you exactly to what you need to explore next. Whenever you get stuck, don't panic. Go back to your books, lectures, or notes and study that part carefully. But don't memorize. Understand. Ask questions. Try to see the connection between what you know and what you don't. Then return to your student on paper and explain it again. Repeat this process until you can teach the topic from start to finish. This back and forth study and teach cycle is the heart of the method. And the more you repeat it, the stronger your understanding becomes. Once you can explain the topic fully, the next challenge is simplification. Remove the jargon. Use plain language. Use analogies or stories. For example, instead of saying force is proportional to mass and inversely proportional to the square of the distance, you could say objects pull on each other, and the farther apart they are, the weaker the pull. Bigger objects pull harder. Or you could tell a story. Imagine the Earth is a giant magnet, and it's pulling everything toward it. Apples, oceans, even the planets. The bigger the magnet, the stronger the pull. Simple, relatable examples make ideas stick in your brain. If your explanation is wordy or confusing, you probably don't understand it as deeply as you think. Keep refining until it feels natural. This method works for everything, not just physics. When I wanted to understand why birds fly, or how a drum makes sound, or why atoms behave in strange ways, I applied the same process. Study it, then teach it, then simplify it, then refine it. That's how you build a deep, intuitive understanding of anything. The process itself is fun, because every time you get stuck, you have a small puzzle to solve. Every time you find a gap and fill it, you get a little thrill of discovery. And unlike memorization, which can feel boring or stressful, this method makes learning exciting. Teaching is the key. You might wonder why explaining something to someone else helps so much. The answer is simple. Teaching forces you to organize your thoughts. You can't explain chaos. It exposes your gaps and strengthens your memory by connecting ideas together in a meaningful way. When you explain, you're not just repeating words, you're constructing knowledge in your mind. I used to carry scraps of paper and pencils everywhere just to explain ideas to myself. I would write things down, speak them out loud, test my understanding on anyone who would listen, even if it was just my reflection in a mirror. That act of creation is the essence of learning. I always said, what I cannot create, I do not understand. Teaching is creating. Another tip, be patient with yourself. Learning like this isn't fast. It takes time, repetition, and curiosity, but the rewards are enormous. Once you truly understand something, you can remember it for life. You don't have to cram, you don't have to stress, and you don't have to fear forgetting. The knowledge becomes part of you. You can apply it, explain it, and even discover new ideas from it. That's the power of deep understanding. So forget memorizing for now. Be curious, ask questions, teach what you learn. Go back when you get stuck. Simplify and refine. Explore analogies. Tell stories. And remember, every gap in your understanding is not a weakness. It's a clue, a treasure map, guiding you to the next level of knowledge. That's how I learned physics, and that's how you can learn anything. Knowledge isn't about repeating words. It's about seeing the world clearly and then being able to explain it so anyone else can see it too. That's learning the Feynman way, and it's one of the most exciting adventures you can ever go on. Now that you know the basic idea of learning like Feynman, studying, teaching, and simplifying, let's go deeper. In this part, I'm going to show you exactly how to apply this method to real topics, how to uncover hidden gaps in your understanding, and how small curiosities can turn learning into an adventure. I'll also share some quirky examples from my own life so you can see how even the strangest questions can lead to big discoveries. By the end of this part, you won't just know how to learn, you'll want to learn everything. Imagine you're sitting down to learn something completely new, something that at first feels confusing or intimidating. Maybe the way electricity flows through wires, or how atoms bond to form molecules, or even why the sky is blue. Most people would open a textbook, read a definition, maybe highlight a few sentences, and hope it sticks. But that method rarely works. Memorizing words and formulas without understanding them only creates the illusion of knowledge. You might be able to repeat it on an exam, but the moment you stop thinking about it, it slips away like sand through your fingers. Here's where the Feynman method changes everything. You start by picking a small, specific part of the topic. Don't try to swallow the whole concept at once. You'll overwhelm yourself. Focus on a single piece. Let's say you're curious about why magnets attract or repel. You study the basics first, maybe watch a short video or read a simple explanation, then take a blank sheet of paper and start explaining it. And here's the crucial part. Imagine a child is sitting next to you, waiting to learn. Write down your explanation. Speak it aloud. Act it out if you like. Pretend you are at a blackboard in front of a classroom. As soon as you do this, something fascinating happens. Your mind immediately notices the gaps in your knowledge, the parts you thought you understood, but can't explain clearly. You might say, magnets attract because of magnetic fields, and feel confident until you realize you can't explain what a magnetic field actually is, or how electrons move to create it, or why some materials are magnetic and others are not. Suddenly, the topic that seemed simple becomes a puzzle, and that puzzle is pure gold. Most students panic here. They feel embarrassed or frustrated or think they've failed. But the Feynman approach says, this is where learning happens. Confusion isn't the enemy, and it's your guide. Once you see the gaps, go back and study that part again. Ask questions, find examples, explore analogies. Maybe look at a video of iron filings reacting to a magnet. Maybe build a small experiment at home. The point is, don't just memorize the definition, understand it. Then, return to your student on paper and explain it again. Repeat this cycle as many times as necessary until you can explain the concept from start to finish smoothly and confidently. With each repetition, your understanding grows, and the abstract words you read slowly transform into a vivid mental picture you can see and manipulate in your mind. Here's a tip that most students overlook. Curiosity drives retention. The more you wonder about something, the more your brain pays attention. I often ask questions that seem silly at first. For example, I once asked, why does a spinning plate stay upright when it spins but fall when it slows? It wasn't required for any class. It wasn't on any exam, but by exploring it, I ended up understanding angular momentum in a way most students never do. Tiny, curious questions like that act as sparks. They light up your mind, make learning exciting, and often lead to insights you never expected. Another time I asked, why does the moon shine at night? Simple question. But when you dig deeper, you start to see the connection between sunlight, reflection, and the movement of celestial bodies. Even small curiosities can take you on big journeys. After you've explained something and found the gaps, the next step is simplification. Don't just use plain words. Create analogies, drawings, stories, or metaphors. If you can't make an analogy, it probably means you don't fully understand the idea yet. For example, when explaining how atoms bond, you could say, think of atoms like puzzle pieces. Some pieces fit easily, some need adjustment, and some just don't fit at all. Or imagine atoms as people holding hands to form a chain. Some hands connect tightly, some loosely, and some can't reach each other. Suddenly, what seemed complicated becomes vivid, memorable, and even fun. Here's another tip. Build connections between ideas. One small idea can become a building block for the next. For example, once you understand how a magnet works, you can better understand how electricity generates magnetic fields. Once you understand angular momentum in a spinning plate, you can understand gyroscopes, planets, and even why a bicycle stays upright. Learning isn't a collection of isolated facts. It's like building a Lego model, piece by piece. And the more you practice, the faster and stronger your mental model grows. Feynman didn't just apply this method occasionally. He made it a habit. Whenever he encountered a new idea, he immediately tried to teach it. Sometimes to himself in private, sometimes to colleagues, sometimes with playful experiments. You don't have to be a genius to do the same. Pick a topic, grab a blank page, and start explaining. Repeat, simplify, refine, and most importantly, stay curious. Curiosity transforms confusion into discovery, mistakes into clues, and learning into an adventure. By the end of this part, you should see that the Feynman method is far more than a study technique. It's a mindset. It teaches you how to think clearly, spot gaps in understanding, and build knowledge that lasts a lifetime. In the next part, we'll explore how to apply this method to multiple subjects at once, tackle extremely complex ideas, and use advanced techniques to make sure your understanding becomes permanent. We'll also dive into some of my favorite quirky experiments, unexpected discoveries, and strange questions from real life that reveal the hidden patterns of the universe. By the end, you'll see that learning isn't a chore. It's one of the most exciting adventures you can ever go on. Now that you know how to study, teach, simplify, and refine your understanding, let's take it even further. In this final part, I'm going to show you how to apply the Feynman method to multiple subjects at once, tackle extremely complex ideas, and make sure the knowledge you gain truly sticks with you for life. By the end of this, you'll not only learn faster, you'll start seeing patterns, connections, and opportunities everywhere in life, and you'll never look at learning the same way again. Here's something most people don't realize. Understanding one topic deeply doesn't just help with that topic alone. It gives you the tools to understand everything else. The skills you develop, curiosity, simplification, analogy, teaching, are universal. If you've mastered explaining magnets in simple terms, suddenly electricity, circuits, and electromagnetic waves start to make sense in ways that would have seemed complicated before. If you understand angular momentum in a spinning plate, gyroscopes, planets, and even bicycles become easy to understand. Your brain starts seeing connections everywhere, like a spider web of knowledge spreading out in all directions. Let me tell you a story. I became fascinated with water flow once. At first it seemed trivial. Water flows downhill. But when I tried to explain it, I realized I didn't understand how the speed, friction, and shape of the riverbed affected the movement. I started drawing diagrams, imagining the movement of particles, even experimenting with small cups of water at home. That one simple question about water eventually led me to think about air currents, electrons, energy transfer, and many other physics problems. A small curiosity turned into a web of understanding across multiple topics. That's exactly how Feynman thought. No question was too small, and even seemingly silly ones often sparked the biggest discoveries. To apply this method across multiple subjects, start with small specific pieces. Pick one concept in physics, one in history, one in language, or any combination that interests you. Study each just enough to grasp a basic idea, then explain it. On paper, out loud to yourself, or to someone else. Look for gaps, simplify, create analogies, and repeat. Once you've mastered a small idea in each subject, begin to look for connections. How does a historical invention affect scientific discoveries? How does language shape thought? How does music influence math patterns? These cross connections are what make learning permanent and meaningful. Visualization is another powerful tool. Whenever possible, draw diagrams, sketches, or mental images. I often sketched physics problems with arrows, circles, and lines to represent forces, motion, and energy. Even imperfect sketches force your mind to organize the information spatially, not just verbally. A drawing can reveal relationships that words alone cannot. Try drawing a model of a molecule, a planetary orbit, or a historical timeline. Suddenly the concepts become tangible, and your brain starts holding them in memory more easily. Curiosity and playfulness go hand in hand. Some of my most valuable discoveries came from playful experiments. I would spin plates, drop magnets, play with small mechanical toys, and just observe what happened. These were often unrelated to my formal studies, but they taught me to notice patterns, question assumptions, and connect ideas creatively. Even asking why about ordinary things. Why does a drum sound different when it's bigger? Why does the moon shine? Can spark hours of thinking and lead to deeper understanding. The more curious you are, the more your brain is engaged and the easier it is to retain knowledge. Memory itself is strengthened by this process. Once you can explain a concept clearly, don't stop. Teach it again. Write it down in different ways. Use analogies. Record yourself and listen later. Summarize it in your own words. Each repetition strengthens the neural connections in your brain, turning knowledge from a temporary memory into a permanent understanding. You're no longer memorizing facts. You're building a mental model of the world. And once you have that model, you can use it to understand other, more complex topics with ease. Here's a practical exercise. Pick a topic you find challenging. Write it down on paper. Explain it out loud. Identify 3 points you can't explain clearly. For each, research, experiment, or think until you can. Then simplify, create an analogy, and teach it again. Repeat until you can explain the entire topic without hesitation. This might take an hour or two or a few days, but the payoff is enormous. You'll notice a confidence in understanding that memorization alone can never give. And there's another hidden benefit. This method trains your mind to think independently. Most students are trained to follow instructions and repeat what teachers say. But by explaining, questioning, and simplifying, you train your brain to think critically. You learn to notice patterns, ask questions, and make connections that others overlook. You become a problem solver, not just a student. I want to share another quirky story. When I was younger, I once asked my friends, what would happen if you poured water on a spinning top? It seemed silly, but the experiment made me think deeply about stability, rotation, friction, and force distribution. That single playful question led to hours of thinking and teaching myself concepts that later helped me understand more serious physics problems. Sometimes the most ridiculous questions lead to the most profound insights. Always allow yourself to ask them. Let's talk about advanced applications. Once you master the Feynman method, you can apply it to extremely complex ideas: quantum mechanics, economics, historical events, biological systems, or even abstract philosophy. The approach is the same. Break it into small parts, explain it in plain language, simplify and repeat. Over time, what once seemed impossible becomes understandable. And the more you apply this across disciplines, the more your brain starts seeing universal patterns, the underlying logic of the world around you. Before we finish, remember this. Learning like Feynman isn't about exams, grades, or impressing anyone. It's about thinking clearly, understanding deeply, and seeing the world differently. It's about curiosity, creativity, playfulness, and persistence. Each gap in your knowledge isn't a weakness. It's a signpost pointing you to the next discovery. Each mistake is a clue. Each question is a spark. And each explanation you give to yourself or someone else is a step toward mastery. So here's what I want you to do after this video. Pick a topic that excites you, grab a blank page and start explaining it. Speak it out loud, draw it, teach it, simplify, repeat, explore connections, ask strange questions, follow your curiosity, and most importantly, enjoy the journey. Because when you learn this way, knowledge isn't something you store in your brain. It becomes something you live, something you use, and something that changes the way you see the world. Learning like this isn't just a technique, it's a mindset. It's a way of life, and if you follow it, you won't just know things. You'll truly understand them. You'll think clearly. You'll see patterns others miss. You'll connect ideas in ways others can't. You'll never stop learning, and every discovery will feel like an adventure. That is the Feynman way, and it's one of the most powerful gifts you can give yourself. So take it, apply it, and watch how it transforms the way you think, learn, and live.